Good afternoon, everyone. Today I would like to present my research, which is titled as Solar Power Aquaponic System for Sustainable Food Production. It's for author with Pak Andi and Pak Istardi. Slide, please. Next slide. Okay. This one the background how we do the research that's we think about urban challenging that's rapid urban population growth and then security for agriculture and increasing demand for fresh produce. And then current aquaponic welfare high frequency and stable electricity grid and then manual monitoring requiring the specialized technical knowledge, and then we get the solution approach to integrate the IoT and solar energy and aquaponic system. Next slide, please. Yeah, this one the identify the research gap that we identify for few. The first one, the next of holistic water type, the one complete system combining monitoring automation and then renewable energy, and then the second one is limited energy aware design and using intelligent power management strategy, and then the third one about this absence of validation or comprehensive performance testing with real experimental data. And then the last one about the implementation, get vision and fund global trend and particle smart and scale adoption. Next slide, please. So this one about the system architecture that overview, the view process. We have this aquaponic subsystem with the fish tank, and then we have the droplet, and then we are filtering, and then we combine got the IoT control system with the ESP32 sensor up in plus the aquator, and then we combine also with the solar PV subsystem with the 20 with big panel and 18 amp house battery. And then the key component that we use the ESP32 controller, and with the pH sensor and temperature, and then RTC module, and then we combine with the pump and also fish feeder based on this dashboard with the protocol and GPT communication. So next slide, please. Okay, this one the aquaponic nitrogen life cycle, and then we have a few process to produce for this one for fish tank, and then fish tank to produce this ammonia from the fish service, and then from the fish tank and the flow to what we call this biofiltering, with we convert it from the ammonia to the nitrate, and then the plants absorbed by plants, and then come back with the clean water to return to the tank. We can say that it is a closed loop ecosystem with zero waste system. Next. And then we integrate the solar power system calculation with this total, we estimate this 42 wake hours per day for overall usage for the system, and then we integrate with the solar sizing and select that we decide to select the 20 peak per panel, and then we also use this battery sizing with the selected 8 hours per hour. The next slide is next slide. Okay, then we do this experimental validation for 30 days, and then the testing period from the last March 1 to 30 is 2025, and then with the location with the verified Aquaponic garden in Batam, Indonesia. We control about the water quality, about the pH and temperature, and then also we do this energy check for the energy performance for the tree, and then also we check for the automation for how to do the for feeding and then pump circulation. And then we check for this biological outcome and fish, how the fish grow, and then plan health assessment, and other modality for tracking the fish. Okay, next slide, please. Okay, the result water quality is performance we control for the stability, and then we optimal tolerance with 6.2 and then 7.3, and then we also control for temperature control. This we got the result about the 20 30 degrees Celsius mean time is 27.2, and then daily fluctuation we can get this 2.1, and then above critical, and then we have this 100, and then water quality maintained within optimal parameter for fish, plant, and bacteria. Next slide. And then the result for energy performance, we achieved this 100% solar energy autonomy with zero grid electricity depending. And then battery voltage with 11.8 and 13.4 for health during maintenance. And daily energy harvest, we got this 60x watt hours, and then 62% above requirement. And then with this the cloudy rate, and it's 48 hours and consecutive day survive. And this we have this split mode and for optimization and before optimization we have this 36 watt per day, and then continuous operation. And then after optimization we have this 11.8 watt hour per day, and then 5-minute break interval, and then we can conclude that 67% energy reduction. And then we have this biological performance. And this performance, we have this we have the catfish, and then we have the totally number of the fish identities we put on the mortality rate and zero, and then weight again about from the increasing from the 35 grams to the 47. And then plant performance that we can try for this we call this patrol, and then explain harvest 30 by day and 20 extended hike 20 and 25 and healthy green coloration with spinach and what we going to grow absorb harvest ready by day 25. Overall head is 95% healthy average annual nutrient defense symptom. So we can conclude the automated system maintain optimal condition for both fish growth and plant production. Next slide, please. This one, the novel contribution of this research. The first one, we ended through an integration. First, validated prototype combining IoT monitoring, automated control, and solar power in single system with 30-day operation data. And then the second one about energy automation demonstrated that 67% energy reduction through we use the SP30 split implementation with actual measure data. And the third one, the comprehensive validation and complete performance metric with the pH control, and the temperature also we use the 98.5% above the BAM reliability for 94.7% for uptime. And then user-centric design, we does what with the sub-segment latency stored critical analysis, and then manual override as for multi-spot. So bridge the gap between advanced global research and practical smart-scale implementation. So one the limitation and future research direction is currently limited. We limit the parameter we use is only pH and temperature for control, and then no like the DON and for ammonia control for the sensor, and then for current we use also by reactive control based on predicts by ICAE. And then small scale we use the 150 liter system scale if unvalidated. And then manual pH just no automated dose meaning system. So in future I think that is better to get integrate with the artificial integration, and also can put multiple sensor for expansion, and then also maybe you can integrate to sensor fusion, automate those maybe save the pH neutrality for production system. And then better also to get to scale off more bigger than the current research for the 500 to 1,000 liter commercial for commercial purpose. Next slide, please. This one, the conclusion that is successfully demonstration about the fully automated, the energy efficient and user-friendly smart aquaponic system with we did the achievement about the 100 solar energy automatic completely independent from the grid electricity, and then 68.5% and to 99.2 personal automation or reliability. Minimum intervention required, and 67% energy reduction through the intelligent power management, and then we have this zero fish mortality for proven biology viability. And then scientific contribution, we have the comprehensive integration, this validated end-to-end system with 30-day operation data, and then energy optimization demonstrate partial for management strategy. And then the one implementation blueprint and a replicable design for the region. And we have the validated performance and comprehensive metric across all the subsystems. This is the provide particle evidence for IoT related and renewable energy adoption for sustainable urban agriculture in the household and student context. Okay, thank you for my present for today. Thanks. We'll back to the present.
Okay, thank you so much for Mr. Adhiguna.
Yeah,
Mr. Adhiguna, thank you so much. Give applause to Mr. Adhiguna. Can you explain what salah satu program you are doing from the Politeknik? Informatika. Okay. Okay, thank you. Is there any question that want to give to Mr. Adhiguna?